Swayam Prabha. Digital India. Educated India.
Okay, all friends. So let's start with our next session. In this session, we are going to talk about buffer overflow attacks and different ways to prevent these attacks, or different techniques that we can using which we can prevent these attacks. Before going to the lunch break, I have given task to you regarding writing C code where you can copy data from one array to second array using our own user defined function, not using strcpy. I hope you must have done it. Yes or no? How you have done it? Because the first question that you should ask me, that you haven't asked, whether to take data from user or some fixed string that you have to copy. From where you got the first string? You want to copy string 1 to string 2, but the string 1 data from where you got? Have you got it? Which function you have used? GetS function that you have used, right? Or any other function that you have used other than getS? Scanf. How many of you use scanf? Great.
String you can actually also consider white spaces. So percentage S will be sufficient for my entire name. So space will just cut off the rest of the
Okay.
getS sometimes has some buffer issues. So
yeah, because it doesn't know the size of the.
Okay. So two things, one is scanf and other is getS. Let's see what kind of code people have written and what can happen. Let's start with the getS function. So something like this. Visible now? I haven't done the code for string copy. I have just used the library functions. So if you use the first function getS, that is what my first job is. From where you get the data? You are getting data from user. So suppose you have used function getS. When you compile your code, I am not saying I have started running the code. The first thing is I want to see all the warnings or the errors my compiler gives. This is not my compiler, this is GCC. Okay. So our current GCC is giving this message, warning, the getS function is dangerous and should not be used. Why it is saying so? Why it is saying that it is a dangerous function to use? It has a limited buffer, but buffer is for function or buffer is for the variable? Buffer for function. But any other thing?
it probably rewrites the adjacent buffer as well if the string is given that is exceeds the array limit.
Okay. So let's do one thing. Where is the data? Is your code waiting for keyboard input which is not supplied? So I need to provide the data for it. Okay, what I will do? Yes, yes, sure. Now,
It's still not as legible. But the screen show.
now, it's okay. Okay, so what I written is a character array S of size 10 and I have initialized it. The statement is printf enter string. I am using getS function to read it from user. Printf enter string is, that's it. Okay, there is input required to run it. I am not going to show you here. Okay. So, the data that I have entered is coming here A B C D E F G H I J K. How many characters I have entered? 11 characters getting stored in character array S of size 10.
Actually, this
User can enter unlimited data there, but my buffer size is 10.
It's overwriting the address.
Where is overwriting? But I am not able to see it.
The instructions pointer.
Instruction pointer. Are you getting the problem here? The size is 10, but I am writing 11 characters. Actually, do you know how many maximum characters I should enter? 9. I should enter maximum 9 characters, because if I want to make this character array as a string, when I talk about string, it is a valid character array. To make a string valid, I require to have /0 as a terminating character. So, I can maximum enter 9 characters, so that the 10th character will be filled by system /0, and that is the reason the compiler here is showing us a message. And that message is the getS function is a dangerous function to use, but I think most of people have used it. What should be done? So, first thing is the input taken from user is more than the buffer size that I can store. So, first thing is processing is going to be problematic at the first stage. So, instead of getS, which other function you can use? Let us say scanf. So, if I use scanf, what will happen? Instead of this, okay, I will modify it. So, some data will come probably same size. Again the scanf is not allowing me to enter 9 characters only. I need to modify the simple scanf statement that I am writing. I need to modify it. How I can modify this percentage s? I need to modify to make it percentage ns. N stands for the number of characters that I want to capture, maximum number of characters I want to capture. So, this percentage s need to be replaced by percentage 9s, so that I can take only 9 characters as an input from user. User can give 100 characters, but only the first 9 characters will be captured and stored in s. With me everyone? Then only I will be in position to, now my data, the input data is not doing overflow of my array. So, the first hurdle I have crossed. The next thing is, now I want to copy the data from S to S1 or from S1 to S2. Okay? When I am reading data from user, I know what is my array size. So, I have put the restriction there, I can only read only n minus 1 characters and store in my first buffer S1. Now, I am going to call my function string copy or any other function, your own function string copy. When you call string function or the function with by passing the parameters like arrays, the arrays are passed by reference by default, right. So, actually if you see the prototype of function strcpy, have you seen the prototype of function strcpy? Prototype function declaration. What is the declaration? There is a character star destination, comma constant character star source. So, here it means I am getting the in the function strcpy I have the pointers, the addresses, but I do not know what is the size of destination and what is the length of source. What is the size of destination and what is the length of source. So, it may happen that my source is having length 10, but the size of destination is 5. See, I am giving a simple idea. Let us say this room is having 100 chairs. So, the size of the room is 100, the length right now let us say 30. So, length is 30. Instead of 30, suppose I am coming from Pune and I am coming from industry, many people wanted to attend my lecture. So, 130 students come into class. What is my sitting arrangement? 100. The size is 100, that is destination size is 100, but the length is 130. Are you getting me? So, in this function strcpy, there are 2 parameters passed, one is for destination pointer, other is the source pointer. As those are pointers, I do not have any kind of information that what is the size of the destination and what is the length of the source. That thing I come to know only if before calling the function I can check it. Once I give a call, I do not have anything. So, it may happen that size of the destination is 5 and the length of the source is 10. So, I am trying to feed 10 characters from source to the buffer of destination buffer, which is containing only size 5. Is it not buffer overflow, the same thing that we tried in the getS or scanf? Similar thing is there. So, the function that we are using from our let us say first year or have been taught to us, use getS, use scanf, FPL in our SPPU there is a first year FPL function programming language. So, there is a we teach C and C plus, I think C only. So, the first function that faculty member teaches is getS, scanf, strcpy, and what has been taught to us in first year, somehow it becomes akshara for us. Akshara means the which is not going to die, akshara. First standard we learn ABCD. So, in first year of engineering we learn strcpy, getS. So, it remains with us always. So, that idea of strcpy, which is buffer having buffer full attack, has been taught to us, or we are learning it knowingly or unknowingly, that use this function even if it is dangerous to use. Why it is dangerous? Because you want to create the buffer overflow attack. You may say, why I have started this buffer overflow attack or activity today in this session? There is a reason. Start it now. This is a list of attacks recently happening on different tools, different applications, which are buffer overflows. The CV 2018, that is the attack vulnerability discovered in 2018. The buffer overflow vulnerability is os.symlink on Windows in C Python. The next, again a buffer overflow attack. There is a function called as a base64d, which is a part of SMTP listener. That function is having the buffer overflow attack. CV 2018 5002, it is a Adobe Flash player that you use. It is having stack buffer overflow attack vulnerability. 2017, I am just listing 4. We are using Skype nowadays many times. When I go for conference, and if the conference is in let us say not in Pune, I am not interested in going there, sitting in Pune doing my job, do the presentation, I use Skype. Let us see what happens there. The Skype 7.2, 7.35, 7.36 are having buffer overflow because of stack. We are, when I joined IBM in 2006, from that or actually before that onwards, I am coming to this attack buffer overflow, and still the attack is coming today also, which I started learning in 2006. Today is 2018, or about to finish 2018 now. It is more than 12 years, but still the attack is there, buffer overflow. Why it is so? And that is, we need to understand this attack and how we can prevent it as a coder, as a software developer. So let us go one by one. If you have any doubt in between, you can stop me. Buffer, it is a data storage area inside computer memory. It can be stack or heap. There is a reason I am saying stack or heap, because there can be memory which is statically allocated or a compile time memory, or I can have the runtime memory, and again that can be overflown. It is intended to hold predefined amount of data. If more data is stored into it, it spills into adjacent memory, what our friend has suggested correctly. The data goes to the some other location, probably not given to my program or given to my program, and it is going to corrupt it or override the data. If now the data that I want to store and it is going to overflow, it is going to overwrite some other data, other memory, that code, that data that I am writing on some other locations, if it is a executable code, what will happen? Actually that executable code will start functioning, and it will take me to some different location, different code, probably will give the attacker a chance to take root access of your system. We stated something like privilege escalation in the morning. That is possible using this small error that we people have made. Let us see what happens here. There is a buffer, there is a character array A of size 8, and there is a variable B which is of type short integer. So you can see there is a 8 byte for A and 2 bytes for B allocated. So initially let us say some data is there, all zeros, and B contains value 3. I am using getTest function. Favorite, we started with that, right? And the data I have given is overflow. So what is happening is now that S, actually I have done S here, do not say this is S, it is the ASCII value of S, because when you write anything in character array, ASCII value of that is getting stored there. Okay? So do not say it is O, it is single quotes O. When it say V, it is not V, it is single quotes V, that is the ASCII value of O, ASCII value of V, and so on. So in first B, where you can see S there, it is actually ASCII value of S is getting stored. I have not modified B, I have not read value of B yet, I have just performed get as A, but value of B, it was there 3, now got changed to 0. Okay? So it means our data, the entered data by program or by input is going to overwrite some other areas, adjacent areas. Okay? Look at this code. Identify this problem. There is the array A of size 5. The data is stored there 1, 2, 3, 4, 5, and I am trying to print array 5. What is the problem? What is the problem here? My array size is 5. The valid locations for me to access this array are A0 to A4 only. The array index, this is a C code, the array index starts with 0, ends at size minus 1. The size of here A is 5 here. Okay? So it is valid locations for me are 0 to 4. And what I am trying to do? I am trying to access the 5th location, that is actually the 6th location of the array, which is not there. It is not there for array, but it is there in the memory. And I am trying to access it, which is an illegal access. Okay? And that is the reason I am getting some different data, garbage data. Very simple, right? How many times we are making this mistake? Many times. Right now I have given a value 5, but actually our program, because many times we write a for loop or while loop or something like that, and we write for I equal to 0, I is less than n, and that value of n is actually crossing the boundary of array, and your I is that number, that array, the variable I is containing that number which is crossing the array boundary. I am trying to access it. Hey Kai, what is this? This array of 5 is same as that array of I, where I is actually moved out of the array boundary. Let us see what happens here. Again there is array I, array of size 5, there is stored data 1, 2, 3, 4, 5, and now here in this array I am trying to write value 41 from 0 to 255. I is less than or equal to 255. So I will enter 256 elements in the array A, in the array having size 5. In the first case, when I try to access array of 5, probably that location is not modifying my return pointer or some other FB pointer. But now when I am crossing that limit, there is a location where my return pointer is modified, and because of that now I am getting the message segmentation fault. Okay? And there is a core dump. When I see this core file, if I open this core file in GDB, I can actually see where the mistake is, where what data actually got written on line number array 6 location, 7th location, and so on. Okay? Such kind of mistakes I do not know about you, but let us say people like me, they are making every day. Okay? I need to correct it. Now I am saying that the data is getting overwritten into some adjacent memory locations. What are those? To understand that thing, let us understand first the memory layout of any program in Linux. What happens is, first one is ARGV and ENV. ARGV stands for argument values. The command line parameters that I can pass to the variable, to the function or to the program, those are getting stored there, ARGV. Then there is the ENV, those are called the environment parameters required for execution of your program. The next one is stack. The stack actually contains the activation records of the functions. Okay? Afterwards I will show you what is activation record also. So those activation records are getting stored in stack, and stack is going down. Okay? There is a heap area where when you allocate memory for any variable at runtime, it can be character pointer, structure pointer, file pointer, the integer pointer, those are getting memory locations, runtime memory from heap area, and that heap grows from bottom up. Below that there is a BSS, there is a data segment, and then the text segment. To understand what is happening here, the next slide I will show you what is actually getting stored, which variables are getting placed where. You may be knowing it. If you know it, great. If you are not knowing, this is some value addition to your skill. So this is a process memory layout. When you talk about 32-bit memory, Linux, I have 4 GB RAM. The first 1 GB RAM is for my kernel, Linux operation system. The next part below that is for my code, data and other segments. So now let us see this slide. There are some variables, integer a. Look at this variable a, which is declared globally and initialized. Can you see it? This is variable a, which is declared before main and initialized data. There is a BSS segment. There is an integer b, which is again a global variable, but which is uninitialized. The uninitialized variables go into that BSS segment. The initialized variables, initialized, global and static variables go to data segment. Now come to the text area. This part, the executable code of our program goes into text segment, okay, or a code segment. Now this variable c, integer star c, the declaration of integer star c, the memory available for c, I am saying memory available to c or memory given to c by compiler is in the activation record of the function main. The memory allocated to this pointer c by the compiler will be available in the activation record of the function main, and this activation record is a part of stack. Are you getting me? And then in this main I am trying to allocate memory for variable c. I am saying malloc 5 comma size of int. Let us say size of integer is 4, 5 into 4 is 20. So 20 bytes of memory will be allocated, whose base address will be assigned to c, and this 20 bytes memory allocation is done from the heap area or a heap segment. Are you getting me? So there is a code segment, there is a data segment, there is a BSS, and now there is a heap area where these 20 bytes are available. Its pointer, its beginning address is stored in C in the activation record of main, and this activation record is a part of stack. Are you getting me? So this is our program layout for this our program. With me everyone? Great. आता गम्मत है. What kind of things are possible? How we means attacker can make use of this idea of memory layout to attack the system. The problem is that the buffer is there as well as the memory layout, the structure. There are two things. Use buffer overflow to write machine code onto stack. So in the stack code, which is after in main there is activation record, I will write some code in my that variable which is available to me, which will overflow this return address of function main. So I can, instead of going to mains caller, mains actual caller, I will go to attacker's function call, and then that attacker's function call can execute. By the way, how many of you know that main, we can write a function which can get executed before main? We can write a function which can execute before main. We can write function which can execute after main. It is not a case that main is the first function and main is the last function. We can write function which can we can execute before main. There is a preprocessor directive called as #pragma, using which we can write this such kind of functions. Okay? So similarly, what I said right now is there is a return address of the function, that is after execution of main, where the control should go. By writing some shell code, some code or buffer overflow code, attacker can tweak, attacker can modify this return address from main instead of its actual caller to the function call developed by the or function body of the body of the function which is attacker has written in the memory, and the control will go to that function, and that function can do any other job. Okay? Here this is possible. And then if it is possible, the rewrite return address to point to the machine code on the stack. What will happen? Program will do whatever we tell it to do in those machine instructions. So it may be RM minus RF star or star. What is RM? remove RF recursively, forcefully, everything. So that is possible. So a small script that, if you remember, I said, okay, I will send a link to you and say give feedback to me. I can send small script like this. Bye bye. What is the goal? My goal, as an attacker's goal, is change the flow of control and execute arbitrary code. That is my code, not the programmer's intended initial code. What is required for it? I require to inject the attack code. Same thing is abuse vulnerability and modify memory such that control will flow. Control will go to the my function. Change of this flow control, it will change. It will modify the code execution of pointer, modify memory location, and then that location will not be available for the actual intended purpose. Read the first line. One of the most used attack methods. We have seen different attacks in the morning, cross-site scripting and all those things, but those attacks talk about web application or browser security. But this attack, buffer overflow attack, is possible if the browser code also contains some buffer overflow. So using that also I can attack the browser and then browser to attack the systems. So that is that important. If you remember, security configuration was at the bottom line. Now I will put buffer overflow below that. Attack code executes with the privileges of exploited process, local and remote code executions. That is, the program is running on your machine or remotely the person is going to attack your system. The thing which is helping me or helping us as a programmer is machine architecture dependent. The code for Linux to make a jump to particular location and then do this attack is different than Windows, because there are different system calls. All those things will come to picture. So machine dependent architecture is helping us as a programmer. Ki buffer overflow attack, if it is possible on Windows, probably it will not have the same code will not happen. Attacker cannot use directly on the Linux machine. He required to write different shell codes. So his attacker's job is more increased. Requires operating system calls, and very important thing is the attacker, he is not knowing what is the size of the buffer. So he requires to do trial and error many times, and then he will come to know, okay, my buffer is getting overflown after these many bytes of data. So then he will write his data in such a way that overflow will happen and code will go to the control will go to the his code. So he requires to do lot of trial and error. And if you remember the first lecture, I said something like logging. That logging activity, if done correctly, if twice, thrice something is happening, the attacker is trying, it will fail. If it is failing 3 times and the 3 logs are generated, then my admin who is looking at the log can stop that process or see who is trying to access that process. So by using that thing, the application getting a trouble because of buffer overflow can be stopped. So this trial and error is helping us also, the programmer also, how I can modify my code or how I can modify system. This activity needs to be done, the trial and error, by the attacker, because he is really not knowing what is the actual buffer size. It may be 10, it may be 100, it may be 1000. I have said something like I can write a code. I mean, attacker can write a code, and we can take a control of the system. Look at this code. This is a shell code. In Linux, there is a command called as sh, which means we can take the command prompt. This is a simple C code. There is a character star name of size 2, name of 0. What I have done is name of 0. It is the first location which contains the /bin/sh. Name 1. Name of 1 is 0x0 /0 kind of stuff, and 0 we can pass a parameter, and then there is a system call exec cve name 0 common name and 0x0. When this program executes, what will happen is given below. You can see the change here, this different location, something like greater than sign, the prompt. But when this program is executed, look at the prompt now. I am able to get the root kind of prompt. I am now root, and then everything is hari. The next slide, now this is our C code, right? How we can write shell code? Whatever the code of that previous C code, the binary version of this code is actually a shell code, which is now in the character array shell code. The first shell code that here is that binary version. The code looks same, integer star return equal to integer star ampersand return plus 2, return equal to integer shell code. What happens now? I have given the return address, and that address is going to execute this shell code. Now what is the shell code looking? Is executing the code, the binary version of that code, and going to get the root prompt again. What is difficult in that? Okay, a simple code written initially in C, converted into its binary version, taken that thing, putting into this code. If I give this code to you, and I will not show you the output file, that is gcc / test and then sh -3.00 exit. If I don't show you this thing, what will come to know about it? What will come to know about it? You will say there is a shell which is a character array, some data, some garbage data probably. It is not garbage. I think now you are understanding it. It is not garbage data. It is /x, /x is a hex data. /x is hex, C0, 80 and so on. You can see the last part, /binsh. Are you seeing it? Here. The last two parts of the shell code, character shell code is /xff, 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 /bin/sh. That is, now I am going to execute. When the control will go here, return equal to integer shell code, this shell code will actually execute this part, and this part is nothing but your going to that particular location and executing bin/sh. The end user, the beginner programmer, is probably not knowing what is happening, and something is getting deleted. People say ki my machine got malware, corrupted everything. From where it has corrupted? It is you are putting some program on your machine which is containing such kind of attack. A small shell code is going to destruct your machine. Going to write shell code? See the steps. Consider the shell code to inject. It not only it can be bin/sh, it can be RM also. Okay. Find exploitable buffer in a program. So now writing first job is simple, but putting this code in others programmer input so that it will overflow that program. See, I don't want to overflow my program, I want to overflow others program by putting my shell code there as a input. That is that tricky part, that trial and error, that trial and error comes here. Find exploitable buffer in a program and estimate address of the buffer. The next job is simple. Inject shell code into the stack memory, override the return address with address of the shell code, and then bye bye, the other program is gone. So writing shell code is also not that easy, but by practice it will come. I am going to show you one book name, Mastering Shell Code, using the techniques given there, or the idea, the way the shell code to be written is given very nicely in that book. By reading those things, see, I am not trying to make you malware developers, okay? But we should know to become anti-malware developer, but we should know how the malware developers are writing the code. I am not on that side, I am on this side. I am not malware developer, and I don't want you to become malware developer. Remember this. So this malware development, this attack is possible. We can do it. As a programmer, how I can stop it? First one, use language which is checking for bounds checking. Tell me the language that you know. Java, Python, C. C checks bound checking. I just taken names. C is not allowing us to allowing the program to check the boundary violation. If it was possible, then we haven't got that array of 5 printed, right, or that segmentation fault, because C language code, the C language by default is not restricting the data to be stored in the buffer of the buffer size. It is allowing me to get data into the adjacent locations. C programming, the C language does not check array bound. C++, no. We require, if I want to develop a software and handle this thing, then use languages like Java and all those things for boundary checking. What is the problem there? This Linux or controllers, whether we develop using Java, we don't use Java kind of stuff for developing controllers or OS, we use C. So our controllers, the daemons, libraries generally, we write using C and C++. It means we cannot use those languages like Java and all those things which can check the boundary. So that option is gone now. If you are not developing such kind of softwares, controllers, OS, then go for those languages surely. But if you are falling under category of system software development, then you are bound to go to C, C++ kind of languages. So now go next level. What is next level? Do your bound checking on your own. You are calling strcpy. Before calling strcpy, first check what is the length of source, what is the size of destination. If your size of destination is less than or equal to the length of the source, then only strcpy call, otherwise give error message. That is bound checking done by programmer, because my code is in C. C is not helping me to check boundary checking. Below one level, don't use strcpy, use our own function. But if our own function is actually a simulation of strcpy, what will happen? The same job which strcpy doing, your program is doing. Look at your code. What you have written, something like for I equal to 0, s of I not equal to /0 plus I, starting bracket, s1 of I equal to s of I, semicolon, ending curly bracket. I am sure you must have done same kind of code. Are you with me? After lunch time, I have asked you to write a strcpy code. If you are not writing strcpy built-in function, you are writing such kind of code only. I am repeating, for I equal to 0, s of I not equal to /0 plus I or I plus, starting curly bracket, s2 of I equal to s1 of I, semicolon, ending curly bracket, and then s2 of I equal to /0. What you have done? Instead of built-in function, you have done own function, but that function is also buggy. So when I say don't use such kind of functions, it means you need to use safe functions. Avoid unsafe functions means use safe functions. What are safe functions here? The first, and to be honest, just come in my first is strncpy. Strncpy will allow me to copy only first n characters. That n depends upon the size of my destination. So I will write strncpy, the destination pointer, what is the maximum size that I can allow, and source code, the source variable. That's it. So avoid unsafe functions, use safe functions. If strncpy still is doing problem, there are functions like strcpy_s, which is safe code to use strcpy. which actually does at the back the boundary checking for us. That str CPU _s function will do the same task of boundary checking, and if you cross the boundary it will halt you, it will stop you, and it will not allow attacker to make the attack. The next level, this is possible for us, right? OS level and the which function to use, how to write function and so on. The other one is called as operating system defenses, and the last one is compiler based defenses. Let us see those things one by one. This is bound checking that I have said to you. Check input length before copying into the buffer. So, str alien of str, check whether it is greater than or equal to size of buffer, that is destination size is more than the length of the source. What should be done? Exit. So, copy will not happen, attack will not happen. So, buffer overflow attack will not happen, the going to privilege escalation will not happen. This is one way. What is second way? Unsafe input functions avoid. What are functions like getS, scanf and so on. So, you can see here getS is having problem. So, I have used written there use fgetS. So, in that, and if you can give the parameter that is file star stream is nothing but std in. You can printf, you can print on the screen using fprintf. Do you know that? We can print on the screen. Suppose I want to write hello world or print hello on the screen using C code. What do you write? Printf bracket double quotes hello double quote complete bracket complete semicolon. This thing can be replaced by fprintf bracket std out, which is the by default standard output device pointer, the string %s comma double quotes hello, data will print on the screen. So, instead of printf I can use fprintf. Similarly, instead of getS I can use fgetS, and the parameter, because fgetS allows me to use size, the number of characters that I can read from the user. So, the characters are s comma the maximum size that can allow user to give input, and then the file stream, that file stream is about my std in. So, using fgetS and std in I can still read data from user, which will not give me buffer overflow attack. Similarly, scanf, the scanf %s we can, instead of %s we can write %ns, where n is nothing but size, actually size minus 1 data. So, scanf will also allow me to read data which will not do a overflow of the buffer, but that we should know, we should learn. The next one is unsafe function like strcpy. It is not strcpy, it is strcat also. Strcat is what? String concatenation, add another string to the first string. Again, there is no check of buffer overflow, we require to use another corresponding function. Let us see here in strcpy there are functions like wscpy, wsscpy, then memory copy and so on, which can perform the overflow. Instead of that, what is suggested is use strncpy, no null termination if src is greater than destination. If size of source is more, stop it. Now, let us come back here, how we can do it. If you remember, I have said something like there is a activation record of a function. The diagram here showing buffer, SFP, return address, str, what are those? Those are part of the activation record of this function. Okay? There is a SFP. This is one called as the one frame, one function frame, one activation record. Suppose there are different functions and this function is getting called. So, the called function, the callee function frame is here. The function is called by another function, its frame will be available there in the stack. Stack is, what is stack is? Last in first out. So, this function frame will be at the top, and before that there is the other function stack frames. So, function A calls function B calls function C. So, in the activation record of function B is in the stack below, then stack contains activation record of B and then stack contains activation record of C. So, activation record of function C is on the top of the stack, C is called by B. So, this SFP is actually going to the frame pointer of B. Okay, SFP is pointing to the frame pointer of activation record of function B. Return address, the function C is let us say called in line number 5 of program of function B. So, the return address contains the location where the control will go back after execution of C in function B. Are you getting me? So, this return address will go to function B, the next line of the function call of C. Now, look at the thing, what is going to happen? I am going to write some data, my buffer is 126 bytes. I am going to write some data which is more than 126 bits, 126 bytes. Let us say I will write 134 bytes of data. What will happen? It will take first 126 bytes into buffer, the next 4 will go to SFP and the next 4 will go to return address, and that return address which was actually pointing to 6th line in function B will now go to the some other address attacker has put up. This is going to happen. I am repeating, there is a str contains some data. I am going to copy str data to buffer is of size 126 bytes. How they are placed? Buffer, SFP, return address and str. If str is having 134 byte length, so first 126 will go directly into buffer properly, next 4 will overwrite SFP, that is the frame pointer gone, and the next 4 bytes change the return address also. So, return address also is gone, something will come there, right, and that something is the thing about the address of the code where attacker wants me to go. Attacker will give me that address where his code is running or his code is lying in the memory, and that code will execute, and that is nothing but you are attacking the buffer, where the buffer is in the part of stack, activation record of a stack, activation record of function, and activation record is the function in the stack, and that is nothing but I am going to overflow the buffer in the stack, that is I am trying to overflow stack. This is nothing but stack overflow attack. I have said two things, one is stack, other is a heap. So, this is stack attack I am going to perform. I am going to modify buffer, that is SFP and this thing in activation record of this function FUNC, and this FUNC activation record is in the stack and attack is possible. Okay? With me everyone? The same thing is happening. strcpy does not check for the boundary checking, it overwrites. So, how we can stop it? The stack, this is a stack overflow attack, this is a buffer overflow, but stack. How we can stop it? The first thing is use safe languages, forget that point is gone for me right now. Mark stack as non-executable, mark stack as non-executable. It means this SFP and return addresses where the code will go and this thing, those will not go to the executable code, other code. Okay? So, that code will not be executable, this code will not be executable. Not executable means there is no way of performing the buffer overflow attack. Buffer overflow will happen, but that corresponding code will not execute. Here if I write 126 bytes of data, the SFP will get modified, return address will get modified, buffer overflow will happen, but the attack, because I am making this stack as non-executable. So, the other code where the control can go, that code will never execute. The next method is called as randomize stack location or encrypt return address. Here for attacker, what is required to understand? Require the attacker requires to understand that he requires to give input which is 134 bytes. Borobar? First thing he will try at 10 bytes, buffer will not happen, then he will give 200 bytes, buffer overflow will happen, but his code will not run because his code is not at 200 location. He will do trial and error, so that he will come to only 130 byte location, that is return address. He requires to modify return address, right? The attacker requires to modify return address so that his code will start executing. Right now the attacker has tried many times and he has found out that if he can modify 130 byte to 134 locations, attack is possible. But if I change the return address location each time the program is executed, the return address location is changed. That is 130 134 nahi, that is changed somewhere. What will happen? Each time attacker try, he will find 134, okay, he will write some data, but when the program is going to execute next time, because the first time program is broken, it has not executed his code, attacker will try program second time, he will give the input 134 bytes, but now SAP is shifted to some other location. So his address will again not come into the executable code, again it will not happen. That is nothing but change the return address location, change the return address or encrypt the return address on stack by XORing with the random string. Attacker won't know what address to use in his string because it is every time it is changing. In the morning somebody asked me what is my signature and I said where you are sitting can be your signature. Okay? So if I want to attack that person, I know where that person is sitting always, but if the person is changing his location, can I attack that person directly? No, because each time I need to find where the person is sitting, and each execution the sitting arrangement is changed. Are you getting me?
Yes.
This is exactly what is happening here. If I can change the return address at each execution, it becomes difficult for the attacker to know where the code will start, his code will start in memory. And there are other functions, other tools are also available like stack guard, leaf safe and others. Let us see those things. The first thing is non-executable code, that is non-executable stack basically. The first tool that we can use other than our system is stack guard. What it does, it puts a canary bit, okay? It puts a canary bit, the red flag is there, red block, that is the canary bit. Look at the memory layout, it is buffer, canary bit, SAP and return address. While using my system, I have used stack guard. The attacker is knowing that after putting 134 bytes data, there is the attack possible. But what I have done now, I have added one more byte in between. He was thinking about 126 plus 4 plus 4. Now I have added 126 plus canary bit plus SAP plus return address, and the canary bit value is not known to the programmer, not to the attacker. Now if attacker writes some data which is more than 126 bytes, the first thing what it does is it is going to override the canary bit. If the canary bit is tampered, if the canary bit is modified, my program will crash there itself. Crash means stop, halt. If the program is halt, what will happen? Buffer overflow happened, agree, but attack, the attack is prevented. The taking the remote access or putting some shell code in the memory and execute it, that is prevented, that is totally prevented by putting this canary bit in between the SAP and the address. This is the first way. The stack guard uses the canary bit so that attack can be prevented. The thing is, if I want to use this stack guard, if the software is there right now which is running state, I require to modify, I require to, the way we compile, suppose there is a C code that I write and I compile, I feel that there is some modification required, I will modify the C code. What I require to do again? I require to recompile the code. Similarly, if the program is there which is already running and if I want to add this stack guard, I require to do this modification to function prologue and function epilogue. Function prologue means the code that executes before the function, and epilogue means the function, the part of the code which runs after the function, that need to be modified. So that work need to be done by the programmer who is going to use this stack guard. The kernel location is now architecture specific, so also it is helping because architecture on system on OS is Windows is different and it is on the Linux it is different. The global return stack, return address is placed in global return stack whenever a function is called and copied whenever the copied out whenever the function returns. So what happens? There is a memory location. Your, let's say, the actual or intended return address is ABCD. This ABCD is stored somewhere in some location. When the return address is reached, what I will do first check is whether it is ABCD, because the attacker has put up there PQRS. This is PQRS. I wanted ABCD. They are not matched. Function call will never execute. Stopped. So this is the way stack guard works. Also limitation, as I said earlier, the code requires to recompile. The way you compile the code, modify the code, recompile. Similarly, if you want to use stack guard, your code is there already running, you have to stop it, compile it using stack and all those things. Checking canary integrity prior to every function return causes a performance penalty, obviously, because every time program is getting executed, I will check what is my canary bit. Earlier, checking canary bit, it was not my job, right? Yeah. Just execute. I get the return address, go there. Now what happens? Before return address and before going to go back to the call, check the canary bit. If the canary bit is 0, okay. Canary bit not 0, stop. So that checking is added more, which is going to give me some performance penalty. Nothing is free, you have to pay other than advice. The next one is point guard. What it does is perform the encryption of pointers. What are the pointers here? The SFP is there, right? SFP return address. So these addresses, if I can change it, suppose this is ABCD and I will write it PQRS. Attacker wants to read it. What attacker will read? PQRS. So he will modify PQRS, but PQRS is not existing. So ABCD is existing, actual PQRS is not existing. So attacker is trying to attack, nothing will happen. That is but encryption of all the pointers. What is required here is again random number. Generate a random number key when program is executed. Each pointer is XORed with this key. So whatever pointers that we have will be XORed with this random number. Why random number? If it is not random number, the attacker will come to know one day or other, one execution or other execution. So has to be the key which is XORed with the pointer need to be randomly generated. Okay? So there is a random number generator which will generate a key. That key is XORed with the pointer, and that encrypted data is stored in the memory locations. Sorry, each pointer is XORed with this key when loaded from memory to registers or stored back into memory. The idea is attacker cannot predict the target program's key. That is the first job, because for if I use some key for encryption, I require the same key for decryption. Have you heard something like scissor attack, scissor cipher?
Yes, sir.
So in scissor cipher we add 3. So if it is ABCD, it becomes DCF. Okay? So that key here is +3. Similarly, if the attacker knows the key, he can decrypt, but the key is generated randomly. Attacker is not knowing the key, so the decryption is not possible. He gets the encrypted text, but decryption is not possible because key is not with him. So attacker cannot predict the target program's key. Even if the pointer is overwritten, after XORing with the key, it will be dereferencing to a random memory location, not the attacker's memory location. So attack is prevented. see what is actually that we are referencing here. So, the fetch pointer is 1 2 3 4, access data pointer is something different. This is attack scenario. Okay. So, 1 2 3 4, I wanted 1 2 3 4. Now, what the programmer has done is he has written instead of 1 2 3 4, he has modified it to 1 3 4 0. So, run time the code will go to 1 3 4 0 and attack will happen. Ata data is 1 2 3 4, written as 7 2 3 9, that is a change data. The attacker will try to decrypt, he will try to decrypt into some number, that decryption is 98786. I wanted he wanted 1340, I got 9786, which is not the memory location, which is not the memory location of the code where the attacker's code is sitting. So, attacker code will never execute, buffer overflow will happen, that everything will happen, but attacker's code will never execute, that I want to stop, right. This is the limitation. Must encrypt and decrypt only pointers. Attacker should not be able to modify the key. Store key in its own non-writable memory page. Are you getting what I am talking about here? Whether can you relate this thing with our trusted computing lecture somewhere? There is a key for again decrypt, for successful execution of my program I require to come back to my original code. So, I require the data actual address is encrypted, I require to decrypt it and then decrypted code should execute, which is my code again. I am not attacker, barabar, no, I am not attacker. So, each time there is an encryption, actual address, encrypt, store, returning, decrypt correctly using the key which I used for generation and go back to my code. The key need to be stored somewhere in non-writable storage by the attacker. So, can it be in RAM, can it be on the secondary device, or can it be in some device which is hardware device where the key is stored for encryption, so that that key will not be tampered. If key is tampered, gone. So, one thing is random number key possible, the key is stored, but where the key is stored? Key is stored somewhere, right, in RAM. If that location in RAM is tampered, is modified, what will happen? If attacker comes to know that when I execute this particular program, a random number key is generated and it is always stored at location 8888. So, he will go to location 8888 and he gets the address, he gets that address, get the location contains the key, he can decrypt. So, can I write this key in some memory location, system or outside or on hardware device which is non-writable by the attacker? See, if I cannot write, then even my system will not write. But at sandbox I want to talk about something like when malware analysts run the malware, they do not run on the direct OS, they run in some sandbox or virtual box or virtual environment. So, they do it, but we are talking about a real system. In real system there is a real OS, host OS I am talking about. So, in host OS how will do it?
Or to maybe a dummy honeypot of sorts.
So, in that case I know that attack is going to happen.
Yeah, so we are preventing it.
So, it means my every program will be running in the virtual box only, because there are 100 applications I want to run, the 100 applications I want to protect. So, it means those 100 applications will run in the virtual box, but there is a memory required, right, and there is a, let us say I am running, let us say my community college website, I require to show some files. So, those files instead of on my host OS, it will be on the virtual box OS, because my website is going to run from the virtual box. So, if attacker is going to attack virtual box, that application, he will be in a position to read the file also. So, that is not going to help me. and I do not know, I am not going to see if I am in testing mode, then I will run that program in VirtualBox and check whether the attacker's program is going to coming to me or demeter zone, I can check it out. But here this is a real system, I cannot try everything as a dummy system, I require to run it in a real life. So, this thing will not happen, you require some other prevention methods. This is another method. Instead of, because what has happened is I require to, for the first case I require to recompile everything, second case I require to encrypt and decrypt, I require a key, I require a random number generator, the key need to be stored somewhere, the key address may be in the hands of attacker. Why to do it? Can you change the locations where my pointers are stored randomly each time? That is the next method called as a ASLR, address space layout randomization. Okay? In our using our Linux machine, GCC and all things, you can, this is very well possible. Okay? Staggered and all things, these are different tools that we need to use it with our code. ASLR, we can use it directly. With ASLR, the predictability of memory address is reduced by randomizing the address space layout for each instantiation of a program. ASLR prevents exploits by moving process entry points to random locations. Because of this, the probability that individual, that is the attacker, is going to exploit this screen is succeeded. We can stop those things. Basically, we can modify these SFRs and return addresses at runtime. Do one thing, if you are in GCC, write simple C code having one variable A and read the value of A as well, and print the value of A as well as print the address of A. Okay? Stop the program, run the program again. When you run the program again, probably what will happen is you can get the same address assigned to A during second execution, third execution, fourth execution. What it means? Your system is giving the same memory location for execution of your program for different levels. If I change it, if I use ASLR, what will happen? Each time the different memory block will be given to your program. So, the attacker is not knowing the starting address of your program, starting address of the particular activation record and corresponding SFP and RET. Stopped. That is ASLR, what it does. These are some of the references that I have used for preparing this thing. There is a book that I have said, something like mastering shell code. If I want to start writing shell codes, that is a very good book. There is another book by J. Foster. It is a buffer overflow attacks, detect, exploit, prevent. Every C programmer, if you want to be a C programmer, should read this book. And the next line that I have said, something like mastering a shell codes handbook is also available there. These are available on net. Okay? So, try to get these books and read. I will talk about this book by secure coding practices in our next session. But to prevent or to write better code, secure code, go to read another book by secure coding in C and C++. Thank you.